In today's session, I will be telling you how to compute the value of a security. So how to compute the method to value security, and I will be using my concept of DCF, which is discounted cash flow. So discounted cash flow is based on the concept that value of an investment is the present value of its future cash flow. Here, the future cash flow which I will be taking is dividend. So I will be forecasting my dividend. Let's say I forecasted my dividend of year 1 as $1, year 2 dividend as $1.2, year 3's dividend as 1.4, year 4's dividend as 1.8, and year 5's dividend as $2. And after that, I forecasted that price at year 5 will be $42. This price is known as terminal value. That is my price at year 5. But I assume the price after 5 years will be $42. It is based on the formula which we will discuss it later. So we forecasted all these cash flow and we tried to compute the present value of these cash flow and add them up. So we compute the present value of all these cash flow and add them up, and then we will get the value of the security. To compute the present value, formula will be cash flow divided by 1 plus discount rate to the power n. So for the first year, the cash flow is $1. Let's say discount rate is 10%. So we will take 0.1. So 1 plus 0.1. Now I am discounting it back for 1 year to the power 1. For this cash flow of 1.2, how to compute the present value? 1.2 divided by 1.1 to the power 2. Now I have discounted it back by power 2 because cash flow is 1.2 for the second year and my n is 2. For the third year, the cash flow is 1.4 divided by 1.1 to the power 3 and so on. That's how I can compute the present value of this cash flow, and this is my present value. Now I will just sum them up and I will get this value, and this is basically my intrinsic value. This is my intrinsic value, the price of the share that should be traded in the market as per me, and it is based on my assumption that these will be my cash flow. This $42 will be my terminal value and my discount rate will be 10%. Of course, this number will be very much affected by the discount rate. If I take the higher discount rate, if my rate increase, the value, the price fall. And if I take the discount rate very high, let's say discount rate should be 8%, but I take 10%, then the intrinsic value or the price would be very high. Now one question arises, that how to compute the terminal value? I just said we forecast the cash flow, that is the dividend, based on the past data, and after that we forecast the terminal value maybe after 5 years, because we assume the company will have a higher growth for a certain period of time. Let's say on this y-axis you have the percentage growth, and on the x-axis you have the time. Let's say for 5 years the company was growing at a very good rate, maybe 14%, but then the company's growth declined and it became 5% till perpetuity. Now when the company's growth become till perpetuity, we compute the terminal value. So the formula is P5, that is when the company's growth becomes constant, P5 equal to this year's dividend into 1 plus G upon R minus G. That is my discount rate minus my growth. Let's say my dividend is $2. My long-term growth, this constant growth rate is 5%. So it's 1.05. Now this will give me my D6. So I can say P5 equal to D6 upon R minus G, and D6 is nothing but this year's dividend into 1 plus G, and this G is my long-term growth rate. People make mistake. People use D5. Don't make the mistake. Also, this will be P5, not P6, because the growth become constant after 5 years. Let's say here the growth was 14%, but now after certain period of time the growth become constant of 5%. So I will apply Gordon growth model from this point onwards. So 2 into 1.05 divided by my discount rate was 10% minus 0.05. I solve it and I get 42. And this is my terminal value, and this is the same value which we have used prior to this. So if in the examination you are given the terminal value, use it wisely. But if you're not given the terminal value, you have to compute the terminal value using the Gordon growth model.